So when I'm looking at these two, they both have x to the fourth. This one has x to the fourth and this one's x to the sixth. So I could take 4x's out of here and 4x's out of here. Looking here at the y, this one has y to the fourth, y to the eighth. I can take out y to the fourth from both of those. So here, no 64. I need x to the fourth, got it. Y to the fourth, got it. So the only thing was 64. Minus x to the fourth, y to the fourth. We need the 25. We needed 6 x's, but we only have 4, so we need 2 more. We need 8 y's, but we only have 4, so we need 2 more. So we take out x to the fourth, y to the fourth, cross that mess out, and I'm left with 64 minus 25 x squared y to the fourth. Again, now we're going to put it into our box. Take the first part here, it goes into this box. Take the last part and it goes into this box. I'm going to do 64. So 64 has 8 times 8. It's got 16 times 4, 2 times 32, 64 times 1. Once we get into the next section, you'll start seeing how you're going to figure out which one you need. In this section, most of them, you're going to need the exact same number. So let's start with 8 and 8. We come to this box. The way we get 25 is probably going to be 5 times 5. But it's negative, so maybe negative 5 times positive 5. X squared. So I'm going to deal them out like cards. This one gets an X, this one gets an X. And then there's 4 y's. So this one gets 2 y's, this one gets 2 y's. Again, going back to chapter 5, whatever was here, and here. So if this one is 5xy squared, then this is 5xy squared, and this is 5xy squared. Again, going this direction, if this one was 8, then this one was 8, and it came from here, which was 8. Here. If it was an 8 here, then it's an 8 here and an 8 here. And so when we're doing this way, I noticed that I actually put the 8 in the wrong spot, but not a big deal. We know that these two have to share something in common. It's not going to be the 8 because there's no 8 here. It's not going to be this one because these two are sharing this one. The only one that's there is negative 5xy squared. That's why it's really important to try to keep a pattern of where you're putting it, and then you'll be able to see it every time. You won't have to worry about it. All right, so here we have x squared, x to the fourth, y to the fourth, and 8 minus 5xy squared, and 8 plus, there's nothing there, so it's a plus, 5xy squared. Double checking our things here, we get 40xy squared, negative 40xy squared. They're opposites, so these two would be 0, and this is what I'd be left with, which is what would I be left with, which is right here, 64 and that one. So now let's look at the steps for factoring. Number 1, we're going to see what we can take out that they have in common. So we just saw that. What do they share before we actually start the rest of the factoring? Your second step, count the number of terms. So far we've had 2 terms. I'm going to show you that in a moment. If you have 2 or 3 terms, then you're going to make a box. If you have 4 terms, we do something called factor by grouping. We have a couple of sections to go through to get to factor by grouping, but I want to leave it there because when we get to this step, we have to decide, are we going to do a box or factor by grouping? And then the last one is make sure we factor completely. So again, let's look at our steps. Our steps say, take out what they have in common. In this case, again, there's nothing that they have in common. Count the number of terms. We got 2 terms, so we know we need to make a box. And I know, like I said before, the box gets a little tedious because of all the little parts. But again, if you stick with your skeleton, you'll have less mistakes. And right now, when you're first learning it, you're going to want that skeleton. And then after you've been doing it for a while, then you can kind of relax on that skeleton. The first term goes in here, and the last term goes here. The only way we can get negative 1 is 1 and negative 1, so I'm going to do that, 1 and negative 1. I know from chapter 5, whatever's here goes here and here. So if this is negative 1, this would be negative 1, and this would be negative 1. to get 81x to the fourth. Again, there might be multiple ways of getting this. A lot of times you're going to see that it's going to be something like 9 times 9, but it might be 3 times 27. I'm going to start with 9x squared times 9x squared and see if it works. Whatever's here came from here. So if this is this, then this had to have been this. Going across, whatever's here and here has to be here. So if this is here, that means this one's here. If this is, these two have to be the same. If this is 1, then this is 1, and that means it came from here. So again, our answer is 9x squared, positive 1, so plus 1, 9x squared, minus 1. Here we're going to get negative 9x squared and positive 9x squared. These two are opposites, so they're a 0, and we're left with what we had when we started with. So let's see if we missed any completely factoring in this problem. So we look at this and we're going to ask ourselves, the best way to do this, probably the first question you should ask yourself, is it a difference of two squares? And if you go all the way back to the beginning of this section, we talked about the fact that in order to be a difference of two squares, it has to be a subtraction and they have to be squares. So looking here at this part, right here, this one's not a difference, so I know it's probably done. I can't take anything out of these two. Nope, they're not a difference. So I'm going to set it off to the side. 9x squared plus 1 is done. Here I'm looking at it. It is a difference. Are they squares? 9 is 3 squared. X squared is x squared. 1 is 1 squared. So I did not completely factor that. So I'm going to make another box to completely factor this problem. 9x squared goes here. Negative 1 goes here. The only way to get negative 1 is 1 and negative 1. So I know this column, negative 1. I know this row, 1. The only way for me to do this, not the only way, one way is 3 times that, 3x times 3x. Could be 9x and x, but I think it's going to be 3x and 3x. So these two share that 3x, and these two share this 3x here. So our final answer, I'm going to go ahead and write it over here. 9x squared plus 1 was the first part, and then when we broke this part up, we got 3x plus 1 and 3x minus 1. Then we double check, did we completely factor? Not a difference. Don't have to worry. Anything I can take out of these two? No. Not a difference. Anything I can take out of these two? No. A difference. Are they squares? 3 is not a square of anything. X is not a square of anything. 1 is 1 squared. But it has to be the whole thing. So this is my answer. Again, first thing we're going to look at is, is there anything to take out that's in common? And in the case, again, there's nothing they have in common. So step 2, create a box because we only have 2 terms. Remember, terms are separated by a plus or a minus. So even there's a lot of a lot of variables there, that's not important. It's separated by a plus or a minus, so there's 2 terms. 16m to the 4th goes here. Negative n to the 8th goes here. Again, I'm going to figure out how am I going to split this up. Early on right now, it looks like we're doing 4m squared, 4m squared. It is going to change. It could be 8 and 2, 16 and 1. Here we have negative n to the 4th and n to the 4th. This is all the same. So n to the 4th, n to the 4th. This is all the same. 4m squared, 4m squared, 4m squared. Coming across, these 2 boxes should be the same, 4m squared. So this is the same as these. And then again, this one and this one are the same. Now, that's what I forgot on the other problem. Put that in there. So again, 4m squared minus n to the 4th, 4m to the second plus m to the fourth. And I double check for m squared n to the fourth, negative 4m squared n to the fourth. And these are opposites, so they would create a 0, and I'm left with that. Now the one thing that we haven't been checking is, did we factor completely? And in our answer here, I can tell you we did not. This is the difference of two squares. If it's the difference of two squares, I'm not done. So this is not a difference. So I can say that part is done. So I'm going to go ahead and set that over here. 4m squared plus n to the fourth. I can take this now and I'm going to factor it further. I'm going to create another box, and it isn't completely factored. It's not right. Or if it's not completely factored, it's not right. So here we go. 4m squared minus n to the fourth. Again, one of the things that I look for when I'm looking to see if I'm completely factored, is it the difference of two squares? If it's not the difference of two squares, then I'm probably not looking at something I can factor anymore. Is there anything that they have in common that you can take out? No, but it is a difference of two squares. This is 2 squared, m squared, n squared to the second power. So it's kind of odd, but we'll make it work. Again, I'm going to try the 2m to see if it works. Here, n to the second power and negative n to the second power. I know this column is n squared. I know this column here is this 2m. Going across this way, 2m. And going across this way, negative n squared. Here I get 2mn squared, negative 2mn squared. These are opposites, so I get a 0, and I got what I started with. So when I broke this part down even more, I got 2m minus n squared, boom, 2m minus n squared, and 2m plus n squared. Now let's step back to this one. And what you'll notice now is, again, I'm just double checking. Did we completely factor it? And again, we did not. So we're going to check, is there anything we can take out? Is it a difference of two squares? Those are our two biggies. So when I look here, I can't take anything out. It's not a difference. Can't take anything out. It is a difference. Is it two squares? 1 is 1 squared. 4, 2 squared. X to the 6th is x to the 3rd squared. So that is a difference of two squared. So I know I can make a box out of it. And this will be our very last problem. I know this has been a long set, but it's a very important set. First box gets the 1. The last box gets the negative 4x to the 6th. 1 is 1 times 1. And again, we know these two are the same, right up to there. These two are the same to there. To get this one, probably we're looking at 2x to the 3rd and negative 2x to the 3rd. So these two get negative 2x to the 3rd, negative 2x to the 3rd. And these two share 2x to the 3rd, 2x to the 3rd. So our final answer, let me move it up a little bit here, is going to be the first part, which we said was done. 1 plus 4x to the 6th power. Then we have 1 plus 2x to the 3rd. Remember, if there's no sign, it's a plus. And then up here, 1 minus 2x to the 3rd. Double check to make sure we're done. Nothing we could take out here, and not a difference. Not a difference, nothing we can take out. Difference, check for difference of two squares. 1 is 1 squared. 2 is nothing squared. X to the 3rd, nothing squared. So I know that's my final answer.